9.1 today. And today we are talking about inverse variation. Inverse variation. Similar to direct variation, remember direct is always y equals kx. Inverse variation is y equals k over x. Which means to find k, we are going to multiply our x and y together. Because x is on the bottom, if I were to graph this, it could not touch the x and y axis. And it would be a curve in the first and third quadrants. So we're going to start by deciding whether something is an inverse variation or not from a table. All right, so here is example number 1. This is what you are doing for 6 through 9. Determine if, that's if, the table is direct, inverse, or neither. All right, and let's say I have a table. It looks like this. I have my x, I have my y. I have 1, 4, 4, excuse me, not 4. How about 2, 2? How about 4, 1? And how about 8 and 0.5? If it was a direct variation, I would take y and divide by x. So I'm going to write that right here, y divided by x. So 4 divided by 1, is that the same as 2 divided by 2? No. It's definitely not a direct variation. Inverse is x times y. So here if I have 1 times 4, is that the same as 2 times 2? Is that the same as 4 times 1? And 8 times 0.5. In this case, they all equal 4. So that's my k value is 4. And so when I write my inverse variation, I would write it as y equals 4 over x. All right, real quick, we're going to do one more. Let's do this one. X, y. Let's go with 0.5 and 1. 2.1 and 4.2. 3.5 and 7. And how about 11 and 22? Well, yeah, but so if we're deciding between a direct variation and an inverse variation, inverse is when I can times the two together and I get the same thing. Direct is when I can divide each one and get the same thing. So in this one, I can take 1 and divide it by 0.5 and I get 2. 4.2 divided by 2.1, I get 2. 7 divided by 3.5, I get 2. So since they divide and get the same thing, this is a direct, like we had in our warm-up today, and we would write y equals 2x. Any questions? Okay. Last thing we need to talk about is finding an inverse. All right. To find the inverse, we use 3 simple steps. Step number 1, find k. And remember, when we're doing an inverse, k is equal to x times y. Step number 2, write your inverse equation. Which again, the inverse equation is y equals k over x. And then step 3, plug in values and solve for the unknown. So here's example number 2. And this is exactly what you are doing for 10 through 18. X and y vary inversely. X equals -4 when y equals 7. Find y when x equals 10, then graph. All right, so we're going to use the first line right here to find our k. So k equals -4 times 7. So k equals -28. Now we write our equation. Y equals -28 over x. Step 3, we plug in 10 and solve for our unknown. So y equals -28 over 10, which is -2.8. It sure is. Last thing we have to do is graph it. Do a little graph here. Now, typically when we graph, because x is on the bottom, we do a curve in the first and third quadrants. But because this one is negative, it flips. So it goes in the second and fourth quadrants.
So if it's negative, it's an opposite.
Yep. And you're really just putting 2 curves there that they're approaching the x and y axis, but they can never touch them. All right, let's see one more. Oh, I could I? Look at that. Look at that face. I don't know. Let's say x equals 2.5 when y equals 100. Find y when x equals 10.
So the first step is we take
Find k.
5 times y.
Yep.
Times
2.5 times 100 is
250.
250. Okay, so then we write our equation. Y equals 250 over x. So now we plug in 10. Y equals 250 over 10. No, you don't.
Oh, 25.
You get 25, exactly. All right, last thing we have to do is graph it. Again, because there's an x in the denominator, it approaches the x and y axis but never touches it. And because it is positive, it's in the first and third quadrant. That's it.
So is
Yeah.
is x always 10?
In these problems, yes.
Okay.
What other questions we got?
So do we divide every time? Like we always put that 10 on the bottom?
Yep.
So how come up top we did something different?
Well, it's just that the problems in the book have 10 today. They're not always 10.
No, but how come up top we did direct?
Well, because we're doing,
And inverse.
right. So these problems are just doing inverse.
Okay.
So it says in the directions, x and y vary inversely.
Okay. All right.
We're good?
Yep.
All right.